Okay, guys, so we'll get started now. Let me start with an introduction. So, my name is Rajan Singh, and I'm an IIT graduate, and so I did my BTech from IIT Kanpur, and I'm a former IPS officer. Now, I run a startup called Concept Owl, and we want to make science and maths like really easy and fun. And we teach science and maths, and more importantly, we also help you learn efficiently. So we teach you how to use your time well and how to make the learning process really effective, right? Of course, today's class is a physics class. I'm not going to be talking about learning methodologies, but that is something that we do in other classes, right? Now today's class is for class 10th CBSE, okay? And we are going to be talking about the chapter on reflection and refraction of light, okay? Now before I start, before I get in the details, right, I want to talk a little bit about the class 10th and board exams and things like that, right? Now many of you would be a little worried, right? Because when you go to class 10th, everybody keeps telling you it's class 10 board exams. Uh, Sometimes you think, oh, it's like something really big or really hard, and the reality is that it's actually not very difficult, right? So science, you have one book and there are not too many chapters, and if you just go with the steady pace, you can very well cover the curriculum, okay? So that's the point number one. Point number two is that we teach you how to learn efficiently, and if you have those learning techniques, it'll be much easier for much more easy for you to learn. So my guarantee is that if you follow the techniques that we are teaching you, right, you'll be able to learn much better in probably half the time, because you will not waste time reading something over and over again, okay? So that is about learning techniques, and now we will get started with reflection and refraction of light, okay? So just give me 1 minute. So let me keep my computer here. Okay. Now when I teach, I want to make it easy and fun and really intuitive, right? The when you sometimes when you read books, and even when you listen to people teaching you, very often you don't get the intuition. It is like somebody just reading from the text. So I don't want to do that. I want to actually give you the real. You should be able to intuitively understand, and it should be fun. It should be enjoyable, right? It should make you curious. You should want to learn more. So I'll try my best to make this session enjoyable, and not just learning wise, but also like should be fun, right? So let's start with some basic questions. So first, let's talk about light, right? Now, how does light travel? So you would know that light travels in straight line. How do you know that? I know it sounds like a stupid question, but let me ask you, how do you know that light travels in straight line? Now, you've read in your books, yeah, great, but how do you prove it to me? Like, can you give me some example? Have you seen some natural phenomenon where when you see and say, oh yeah, this is why I know light travels in straight line? How do you know that? So there are many examples, and I'll give you something very interesting here as well. So the common and simple examples are, let us say, sometimes you see there are clouds in the sky, and when between the clouds, when light is coming, you can see the light comes in straight rays, right? Sometimes in your house or in a classroom, if light is coming through a window, and if there is dust, right, you can see again it's coming straight. Or if you have played with a laser beam, if you take a small, like those toy laser beams, and if you shine it, and when light is going, if there is some dust or there is humidity, you can see again it's going in a straight line. So it's pretty obvious, but there is one very interesting implication of this. So let us say, now you're able to see me. Now let's say there was a wall here, okay? In front of me there was a wall. You're not able to see me. Why is that? That is because light travels in straight line. Otherwise, imagine what happens. Let's say there is a wall. If light did not travel in straight line, then the light reflected from my face could go up and go down, and that could come to you. So that is why we are not able to see things which are hidden behind a wall or they are hidden behind some object, because light travels in straight line. Okay. So now next question, if light is traveling in straight line, okay, light travels in straight line, but what happens if something comes on the way? Right? Now we'll take a simple example of a mirror, but could be any object. Right? So first let's talk about a mirror. So let's say light is traveling and mirror comes, what happens? Now again, I'll not spend too much time. This is something you already know, but I'll just do a very quick revision. Okay, so now with me, right, just stay with me and in your mind, like, answer the questions I'm asking. Right? So let us say you have I have a laser beam or a torch here which gives a laser beam. Now here a ray of light is coming. Okay, so there's a red beam of light coming here, and let us say if I have a mirror here. Okay, what will happen? Pretty straightforward. I'll not waste too much time. You already know this. So it will get reflected. Reflected in what way? It will get reflected such that it will go in this direction, and this is the incoming ray, this is reflected ray, this is the incident ray, right? This is the incident ray, and this is the reflected ray, right? And the reflected, it's going to reflect such that from here, if I draw a line which is a 90 degree, then this angle is going to be this angle. So this angle, I call it angle of incidence, this I'll call angle of reflection, I and R. So I is equal to R. Pretty straightforward, nothing much here, you already know the stuff. The next one is, there is some other property. So as an example, let's say, think about it, let me ask you this. So let's say the beam of light is coming from here, right, and this angle is I. After reflection, instead of going here, is it possible that, think carefully, okay, instead of going here, is it possible that, it comes here? It comes here such that the angle is still R. It is possible to, so what I'm saying is the light goes like this. Instead of that, could it come like this such that this angle is R? Because even then, I would be equal to R, but no, that's not what happens. What happens is, it will not reflect like this, it will reflect like this, so that, and it's such that this incident ray, the normal and the reflected ray, they are all in the same plane. This is what it means. When you say same plane, what is plane? So plane is basically a flat surface, right? So so this whiteboard is a flat surface. So now all these three are going to be on this flat surface. That's kind of, the core idea. So these are the two laws of reflection. Very simple. I'm pretty sure you already know this. Now we'll move to something more interesting. What is that? That is, here the reflection is when we had a plane mirror. Now, what happens if we don't have a plane mirror? We have a different kind of mirror. Now the question is, what kind of mirror, right? So one thing I can do is, so let us say I have a football. Okay, think in your mind, just visualize this. I have a football, okay, and the inside of the football, okay, inside it is coated with silver inside. Now I take this football, okay, I take a knife and I slice it, okay. So this was the football, okay, not drawn very well, but so let's say I take a knife and I slice it like this, right, and this is the surface which is reflecting. Now what do I have? Now I essentially have a mirror which is like this, okay. So this is the side which is reflecting, and now this mirror, which is part of a sphere, because it's part of a sphere, we call it a spherical mirror, okay. So this mirror we call this is a spherical mirror. Okay, one more thing I forgot to mention, which is that I don't want you to take notes now. Okay, I'll give you time to take notes, and I'll tell you how to take notes. So you have to take notes using the methodology that we are recommending, and if you follow that, it'll be very easy for you to learn. Okay, so right now just watch, don't take notes. I'll give you a break, and then I'll tell you when to take notes. So this is a spherical mirror. Now there is another way to get a spherical mirror. What is that? In the same sphere, instead of the inside, so here the inside, this was silver. What if the outside is silver, right? So imagine like, an egg, a shiny egg, right? A silvery shiny egg. And again, I cut like this. Now what happens? Now this is the side which is reflecting. So now I have a mirror like this, okay, where This is the reflecting side. How did I get this? So let's see if I slice it from here, right? And this is this part, right? So now this is spherical, this is also spherical, right? So this is the reflecting, this side is reflecting here, this side is reflecting. Okay, so this is a basic idea of a spherical mirror. Okay, now what are these mirrors called? Now they're obviously different, so they have to have some names and different names. So this mirror we call this a concave mirror, and this we call convex mirror, right? The way to remember this is it's concave, right? So think of your mind, think about the word cave, right? So what is a cave like? Cave will be like this, right? You're entering a cave, so cave will be like this. So this is why this is a, so think of it, so this is why I'm calling it a well, this is not why I call it a concave mirror, but this is a way to remember, right, that this is a concave mirror and the opposite is convex. Okay, till now I'm pretty sure it must be pretty straightforward, right? Okay, now one thing, right, these two mirrors, where did they come from? They came from this sphere, right? Now they'll have, both of these have some property. If they come from the same sphere, they have some common property. What is the common property? Well, they've not come from the same sphere because one was polished from inside, other was polished from outside. But let's say there were two of them similar, right? And we slice them. So one thing which is common is both of them are part of a sphere. And how do we define a sphere? Which number? What is one number which tells you what the sphere looks like? That is its radius, right? So this sphere, this distance from the center to this point, this is the radius. Okay, so now if a sphere has radius, a concave mirror is conceptually, we can think of it as part of a sphere. So which means I can say that, oh, by the way, this concave mirror has a radius. Radius of what? Since it is radius because it's bent, so we say, so this radius, let's say this is r. So this concave mirror will have this radius, and for a mirror we call it radius of curvature. What does the word curvature mean? Curve means something which is bending. Okay, so what we're saying is, look, this is bending. Because it's bending, it looks like, it is part of a mirror. So this is the radius of that bending, radius of that curvature. Okay, so this radius of the sphere is the radius of curvature for this and for this. Basic ideas, like nothing super fancy, but I'm sure you must be able to follow this. Now what I'd like you to do is, I'll now give you one or 2 minutes. Now I want you to take notes. How to take notes? First thing, normally the way you take notes in school, you should not do that. So what do you do normally? And not just today, for anything that we're teaching, we would want you to follow the same methodology. Okay, so normally the way you take notes is, you look at what is there on the board and then just, you just copy it, right? Or this line, then draw the line, then no. I'll give you more time, take more time, but I want you to do two things. One, first understand what is written here, okay? And after you have understood, don't look at the board, don't look at the board. Look at your notebook, and then from your memory, from what you have understood, you reproduce that. If you're not sure, go back and look it up here again, but don't look at it and copy, okay? So look at it, then understand, memorize, not memorize, understand, and then without looking at the board, write down the points on your notebook. This is the way to take notes. We call it taking notes using active recall. Why? Because you are actively trying to recall what you just learned. Okay, so now take your time and write the notes here about the laws of reflection. Okay, laws of reflection. I have given you the two laws, I equals R, and all these three are in the same plane. By the way, I don't want to write everything word by word, because that makes you feel like, you have to copy everything. No, I'm telling you, you have to understand and write it in your own words, so that next time when you read, it'll be very easy to understand. Okay, so write about the laws of reflection, and then draw this a sphere, and then write a spherical mirror, and then write in your own words what is the radius of curvature. Okay, so I'll give you 1 or 2 minutes, do this, and then after that I will resume. I'm standing on the side so I don't block your view. Okay, 30 seconds more, or maybe I'll give you a minute more. Please don't copy. I repeat, do not copy from the board. If it takes more time, that's perfectly okay. Always write from what you have understood. Should not be looking at the board when writing. Write it in your own words. Children, when you are done writing, please on the chat panel on the right side of YouTube Live, please tell me that you have done. Let me know when we can move forward. Okay. Okay, I'm assuming that now you have taken the notes, right? So I will start erasing. Okay, now let me ask you a question. Okay, so we'll figure this out together. So let's say there is there's a concave mirror here, right? So this side is shiny. Okay, light comes from here. This side can reflect. Now I'm not telling you the answer. I want you to think. Okay, so let us say I send a beam of light. So let us say there is one ray of light going like this, another ray of light going like this. There is one more ray of light going like this, right? And there are lots of them. I'm just taking three, right? This is the center of this, right? Now the question for you is, what do you think will happen to each of those three? So let's say this ray is A, this is B, this is C, right? What will happen after reflection? So I wanted to think about this. Now, if you need some hint, think about this way. Remember when we talked about the laws of reflection, right? So we said that, if a ray comes like this, it will get reflected like this, right? So the same principle you have to apply. And one way to kind of develop intuition is, let's say if I throw a ball. If you throw a ball like this, what happens? The ball will reflect like that, right? So it's almost like say a rubber ball getting reflected, right? So now if a ball goes like this to hit the center, what will happen? Same principle, right? It goes here, this is center. Here, if you look at it, right, it's almost like it's a flat surface at this point, right? So this light goes, this ray of light B, it goes and it'll come back, right? Here it is flat like this, so it goes, it'll come back. Now here, if you look at the surface here, right, the surface at this point, the tangent, right, so surface is like this. So here, this is the normal, so it will get reflected like this. Right? Throw a ball, just in your mind visualize. If you throw a ball, what happens? Surface is not straight, it is bent like this. So it'll get reflected like this, and this also will get reflected like this. Now I have taken only, so the interesting thing is this ray A, B and C, all of them are meeting at the same point. Okay. Now imagine if I have not just these three, I have lots of rays, right? What will happen to all of them after reflection? They will all come and meet at the same point. Now you may ask, like, how do we know that? So yeah, so I have only given you the intuition. I have not done a mathematical proof. I agree, right? But it is slightly beyond the scope of your syllabus. So I want to keep it at a level where you can understand and follow. Okay. So I'm just here to take it from me right now that all the rays will come and they will meet at this point. Now think about it, right? There are all these rays going and then they are all coming meeting at a point. So what's happening after reflection? All the rays are going to a point. So when all the rays are going to a point, in English what will you say? What is a good way to say this? We can say that they're all getting focused at one point. Okay? Yeah? So surprise, what do we call this point? We call this point focus. Why focus means, let's say when your parents tell you focus, what is the idea? Okay, don't look here or there, like focus on your textbook or focus on your notebook, right? Similarly here, all the light rays will come to this point, and this point is called focus, right? More specifically, it is called the principal focus. Principal focus. Okay. So what is principal focus? Principal focus is the point where all the parallel rays meet after reflection. Okay, now before I write on some stuff, I want to give you some basic terminology. Now it is required. Okay, I want to give you the intuition first. Now this point at the center of the mirror, this point is name. What is the name? So we don't call it center, we call it pole. Okay, so this point is called pole. I'll use the letter P for this. Okay, P, and this stands for pole. What is pole? Pole is if there is a spherical mirror, pole is the central point. That's number one. This ray B, or this line B, okay, which is touching the pole, and it is perpendicular to the tangent. If I draw a tangent here, this line is perpendicular to the tangent, or this perpendicular to the plane, which is tangent to this point. So this line is called principal axis. Principal axis. Okay. So we have the pole, now we have the principal axis, and the point where all the rays meet after reflection, we call it principal focus. Okay. What else? Which is the other thing that we have talked about? Another quantity for a spherical mirror. Remember the previous diagram that we drew? This can be thought of as it's a part of a big sphere, right? So that sphere, let us say, if this is part of a big sphere, right? This sphere will have its radius. So let us say this is the radius, right? Not radius, so this is the center. So this is the center. Okay, I have used the word C here. Let me not use the word C. It's A, B. Let me call it like D or something. Okay, so C is the center of this sphere. So we call C the center of curvature, right? And this distance from C to P, PC, this is equal to radius of curvature. So right now there are four things that I want you to know, and I want to remind you. Okay, first is the center of the mirror. Okay, we call it pole, number one. Number two, principal axis. Let me just write it here so principal axis. The line perpendicular, this sign means perpendicular, okay? Lines perpendicular to the plane PLA. Don't take notes now, I'll tell you when to take notes. Okay. Line through the pole, right? This line is going through the pole and perpendicular to the plane which is tangential to the pole. Okay, so here through this pole this is one ray, I can have many lines going through this, right? So the line which goes to the pole and it is perpendicular to the surface at this point, it's perpendicular to the plane which is tangential to the surface at this point, right? So this is your principal axis, right? What is principal focus? Principal focus is point where all parallel rays, right? All rays parallel to the principal axis, meet after reflection. Okay, pole, I won't write it, pole is the center, right? And C is the center of curvature, right? C here, C is the center of curvature. And R is this distance from here to here, right? PC is equal to, and we use I'm going to use the term R for this, right? So R is equal to the radius of curvature, right? So now I would like you to take notes. Once again, how do you take notes? So please do not, I request you, please do not copy from here. Read it, understand, right? And then in your own words you write. If you make a mistake, you're not sure, no problem. Look at it again, right? Understand again. But ultimately, even if you take 2 minutes more, 5 minutes more, I don't care. But your notes have to be from your understanding, not looking and copying from the board. Even these lines, etc., you have to draw it on your own. Okay, so I'll give you a couple of minutes. Please take notes now. I'll just move to a side so I don't obstruct your view. By the way, if you have any questions, you can ask me. Just in the chat, you can write the questions. Somebody with the handle Black Knight Gaming, I think, said they did not understand, but now they've understood, so that's good. If there's any question, you can ask me. Please don't copy, take your time, think, understand, only then write. If you forget, that's okay. Please let me know when you're done. Please send a message on the chat panel saying that you're done. Okay, we'll give one more minute, and then after that, we'll move forward. We will leave this video for at least a day or two, so you can watch it again if required on YouTube. After 1 or 2 days, we'll probably remove the video. Okay. Okay, so I'm assuming that all of you have taken notes. In case you need to follow this, as I said, we'll leave the video on YouTube for at least 1 or 2 days, so you can take a look if required. Okay. Now let's move forward. Okay, so now here's a question for you. Let's say there is a spherical mirror here, again a concave mirror, and this is a principal axis. This is your pole. This is, let us say, your focal point F, right? And there is some, maybe let's say somewhere here is a center of curvature, right? Now this distance from here to here, this distance is your R, and this distance R is the radius of curvature. Okay, R is the radius of curvature, distance from here to here. Okay, and this distance is your F, focal length F. Okay, now here's a question. This R and F, do they have some relationship? If so, why? I have not told you. I just want you to think. Visualize this. If the rays are going, if let's say parallel rays go here, they will get reflected and they will come to the focal length, right? Now if this spherical mirror was, let's say, more bent, once again listen carefully, if the spherical mirror was bent like this, which means if the radius of curvature was small, okay, then what would happen? If it was bent like this, not like this, it was bent like this, what would happen? The rays would meet closer, right? Which means the focal length would reduce. But when the curvature is like this, right, then the radius also will reduce. Once again, think carefully. I have one sphere is this. I have another sphere which is like this. Right? Now here, if I cut this portion, when rays go, they will meet closer to this point, right? Because it's curving very fast, right? This rays will come and meet here, right? This ray, all of them will come and meet at this point. Now here, this has a bigger radius, right? So now let's say one ray goes like this, it will come back. Another ray goes like this. It is not curving so fast, so heavily. So this ray will get affected, but come a little farther distance, right? Another ray like this again would come a little farther distance, right? So what do we see? We see that when the radius of curvature is small, this is the observation, right? When the radius of curvature is small, then the focal length also is small. When the radius of curvature is big, focal length is also big. I'm just giving you intuition. I'm not proving it. The proof of this will come in your class 11th. But right now, this is good enough to know this. Okay? Which means R and F have some relationship. Now I'm going to. This is just for intuition. Okay? You don't have to prove it. Just for intuition, right? So we can see that when R is small, right? Here R is small. The focal length is also small. Here when R is big, focal length also is big. And the relationship is F is equal to R by 2. Right? The focal length is equal to half of radius of curvature. Okay? This proof, as I said, will come in class 11. Right now it's good enough to know this. So now let me ask you a question. Okay? Very simple question. So let us say I have a mirror, right, which is cut from or rather this mirror has got a radius of curvature. This mirror has got R equal to, let us say, 60 centimeters. Okay. The radius of curvature is 60 centimeters. And now the question is, let's say if parallel rays of light are coming, once again, if parallel rays of light are coming, after reflection, where will they meet? Okay, my question is, after parallel rays of light, when they're coming here, okay, after reflection, all these rays, at how much distance from P are they going to meet? Answer is, since they are parallel, after reflection, where they will meet? They'll meet at the focus. And the focal length is going to be half of R. So F is going to be equal to 60 by 2, which is equal to 30 centimeters. So these rays, okay, these rays would come and meet here. This is the focus, and this distance is going to be from here to here, right? This distance, right? This distance is going to be equal to 30 centimeters, and this whole distance would be, this is 60 centimeters. Okay, very, very basic idea, but I just want you to understand this. So again, I'll give you like half a minute. Please write this down, okay? Or maybe a minute. I'll give you a minute. Think carefully, understand, then write it down. If you have any questions, you can ask in the chat panel. Please do not copy from the board. Think, understand, and then write it. Okay? Okay, so now I'll ask you one last question, right? It'll be slightly tricky question, so it'll make you think, and with that we will wrap up today's study session. Okay, so let's do that. So I'm going to now ask you a slightly tricky question. Just to remind you, F is equal to R by 2. Okay. Now here's the question. I have a plane mirror. And I have parallel rays of light coming. Okay. Where will they meet after reflection? What do you think? How much distance? Let us say I take this point here. From this point, how much distance away will the rays meet after reflection? The answer is, distance is infinity. Why? Because the rays go like this. After reflection, they'll go back like this, right? So these rays are parallel. So where do they meet? They never meet, which means we can say they meet at infinity. Right? Now, if you look at this, right? Here, what are we saying? We are saying parallel rays are meeting at infinity, and the distance where parallel rays meet, that distance is called focus. So what is the focus of, what is the F? What is the focal length of a plane mirror? So for a plane mirror, focal length is equal to infinity, right? So which means radius of curvature also is infinity. So the question, what does radius of curvature mean? Because this is not a spherical mirror, this is a plane mirror. But this plane mirror can be thought of as part of a sphere of infinite radius. How? I'll show you. So just hold on. Okay. Just follow my logic. Okay. I have a mirror here with some degrees of curvature. Now here the curvature is like this. Now I make a bigger mirror. I take a bigger sphere. Now we can see here, right, that if you look at this portion, it is almost like a flat plane mirror. Here, if you look at this portion, it is curved very heavily. Here the curvature is less. Can you see that? Here the curvature is less because R is bigger. Now if I make R bigger and bigger, what will happen? So it starts from here, then it will start flattening out, flattening out, flattening out. If I make R infinity, it will become perfectly plane mirror. So for radius of curvature, R of a plane mirror is equal to infinity, right? So R of a plane mirror is equal to infinity. Right? And we can see that here also this equation, this relationship holds. The focal length is equal to infinity and R is also equal to infinity. Right? Now again, today I don't want to like cover a lot of things. Just want to keep it simple. So this was a very simple, easy introduction, and we will be conducting these sessions very regularly. So for class 10, these sessions will be conducted on most days at 7 o'clock. Okay. So I'll give you a minute. Please take it down. Then I'll give you some final message. So now don't copy it. Again, think, understand, and then write. Okay, so I'm assuming that you have taken notes. So we'll stop here now. In the next class, we'll resume from here. We will talk about image formation and stuff like that. Right? So I hope you found it useful. I know it was very basic, but we have to start somewhere, and we'll build on this. And as I said, rest assured, right? You will have absolutely no problem. Okay, you will be able to understand the subjects really well, and we will train you with these things. And just to let you know, we are also starting. So we have conceptual. We have a program which has got 3 parts. So one is we are teaching you how to build learning habits. Second, we teach you science and maths. And third, I want to also teach you, train you to develop healthy habits and discipline. Right? So as an example, getting up in the morning a little early, getting up at the same time, then you do meditation, then you do some workout. So essentially you start the day in a healthy manner, and then you enjoy the rest of the day. So we are starting a 30-day program. Those of you interested, please check out our YouTube channel. Okay, you'll see those videos, and that program will start from day after tomorrow. Every morning I'll wake up, and 5 o'clock I'll do a short YouTube live session to motivate you. So we will build over 30 days. We'll build the habit of getting up early, doing some meditation, working out, and then more things that will bring in. Okay, that's a surprise. So thank you for joining, and I'll see you soon. Thank you.